Good morning. See, I am Aher Alka from RBNB College, Rampur. Today we study the chapter Gravitation, and in this chapter we study the gravitational potential and expression for gravitational potential. Now see, what is the gravitational potential? Gravitational potential, it is the potential energy. It is the potential energy. You know, potential energy, the energy, it is due to position of the object. It is called as potential energy. There are different types of energy. Total energy is sum of kinetic energy and potential energy. Now, here we consider the potential energy. Potential energy, it is the work done against the conservative force. Every system always have minimum potential energy. Then, every system tries to minimize its potential energy. Potential energy is given by the formula mgh, where m is mass of the object, g is acceleration due to gravity, and h is the height. Now here, for example, for potential energy or gravitational potential, we have some example. A spring in its natural state possesses minimum potential energy. Any object having the position, and due to position, suppose this is the object, due to its position there is a potential energy, such a way that here we consider a spring, and due to position of the rest position of the spring or natural state, it possesses the potential energy. There is a minimum potential energy. Hence we can say that a spring in its natural state possesses minimum potential energy. Now any object on the earth's surface have a potential energy. That is, when an object is lying on the earth, the object and earth has minimum potential energy. Now the potential energy, it is the work done against the conservative force acting on a body, and it is equal to increase in potential energy. The work done is, work done is equal to the force multiplied by displacement. Here F is the force, dx is the displacement, then work done is equal to force F bar multiplied by dx, which is the work done, and which is equal to increase in potential energy. Increase in potential energy is denoted by du. Here we calculate we find the expression for gravitational potential. Now here we consider the work done. And the work done is nothing but force multiplied by displacement. Now see, Fg, it is the gravitational force, and suppose there is a displacement through dx or through dr. Now work done is equal to, we know work conservative force or work done is equal to, we have the formula, it is force multiplied by displacement. Force multiplied by displacement. Now force is here mg and displacement is dr. Displacement is dr. Now here the force is negative here. This negative sign indicates that is this force, it is opposite or it is against the potential energy, and from this equation we can say that this increase in potential energy, change in potential energy, increase in potential energy is equal to minus Fg multiplied by dr. The increase in or change in potential energy, it is given by du, and which is equal to minus Fg multiplied by dr. Now we have to find here this is the small increase in or change in potential energy. We find the total increase in energy, total potential energy, that is U, and it can be obtained by integrating this equation. Then integrating the equation we get. Integrating the equation we get integration of du. Integrate from both sides, we get integration of minus Fg cross dr. Now this force is against the potential energy, then we get minus integration minus Fg multiplied by dr. Now the force of gravitation, it is according to Newton's law, the force of gravitation, it is force is equal to, it is G m divided by r square, where F is the force of attraction, G is the constant of gravitation, m is mass of earth, small m it is the mass of object, r is the distance between two objects. This is the gravitational force, and we can substitute here. We get integration du is equal to, the minus get plus here, and we take the minus that is minus into minus G m divided by r square into unit vector r into dr. Now this minus becomes plus, you get G m divided by r square unit vector r, and the variable it is dr. Now here we consider the limit, that is initial value of r, it is ri, and last limit is r final, that is the distance varies from ri to rf. Therefore G is constant, m is constant, this m is also constant, then integration of this 1 upon r, it is given by, now see G m it is constant, the integration ri to rf into this 1 upon r square into dr. Here we consider the magnitude. The integration of this 1 upon r square, it is given by, it is obtained by the formula, that is C. Suppose x raised to n, the integration of x raised to n, it is x raised to n plus 1 divided by n plus 1. From this we can obtain the integration of 1 upon r square, and it is minus 1 upon r square, 1 upon r, it is 1 upon minus 1 upon r. The integrations are ri to rf, that is initial value of r to the final value of r. Now integration of du, it is u, that is total internal potential energy. Then we have u is equal to G m divided by, or in substitute the final value or upper limit minus lower limit, we get minus, or we rearrange this equation, that is 1 upon ri minus 1 upon rf, that is we get here rf, ri, then substitute the value of initial value, it is infinity, and you get G m divided by r, and it is minus G m divided by r, it is the expression for potential energy. This is the expression for potential energy. If we substitute the value, that is for Ri and Rf, Ri is infinity, we get it is 0, and U is equal to minus G mm divided by R, which is the expression for, it is the expression for gravitational potential, gravitational potential. Now we find the expression for or connection to potential energy formula with mgh. We can substitute R is equal to R plus H also. Now we find the another expression, that is connection to potential energy formula, connection to potential energy formula, potential energy formula with mgh. Now consider, see the potential energy. First we consider the potential energy if the object it is on the earth's surface. When the object is on earth's surface, now this R is equal to R plus H. Now the object is on the earth's surface, therefore value of this H is nearly equal to 0, R is equal to R, and we get the value of U. It is U is equal to GMM minus GMM divided by R. This is equation number 1. Suppose the object it is on the earth's surface, then we get R is equal to R plus H, H is nearly equal to 0, R is equal to R. Substitute the value in this equation, that is U is equal to GMM divided by R. Now we consider, suppose the object is at height H, then R is equal to R plus H. Then you have the change in or the gravitational potential U is equal to, it is minus GMM divided by R. Substitute the value of R, we get minus GMM divided by R plus H. This is equation number 1. This is equation number 2. This value it is suppose U1, this value it is suppose U2. Then U2 minus U1, we get delta U, increase in potential energy, gravitational potential energy, it is U1 minus U2 minus, that is U is equal to U2 minus U1. Substitute the value of U2, that is minus GMM divided by R plus H, and minus, substitute the value of U1, that is GMM divided by R. If we simplify the equation, we get minus GMM divided by R plus H, minus get plus here, and GMM divided by R. If we find the LCM, then we get R into R plus H, we get GM, it is constant, that is we can write here GMM, it is R minus R, and it is plus R plus H. R get cancelled, we get the value, that is GMM into H divided by R into R plus H. Again we simplify the equation, we get U is equal to GMM divided by R H into R plus H. Now substitute, we have GM is equal to the formula, G is universal constant, M is mass of earth, and it is GR square. Now substitute here, U is equal to GMM, that is the value of GM, it is GR square into mh divided by r into r plus h. R get cancel, then u is equal to, we get, see, this is mgh. This is mgh divided by r upon r plus h. R plus h. This indicates that is mgh into r upon r plus h. If rh is equal to r plus h is nearly equal to r, that is the value of r here, you get mgh into r divided by r. It is 1, that is gravitational potential energy is mgh. This is the connection of this gravitational potential energy with mgh. Thank you.